So before we get started with similar figures practice, let's do a quick review of solving proportions. So we have to cross multiply, so 10 times x is 10x. 60 times 3 gives you 180. Okay, so we have a one-step equation, 10 times x equals 180. Divide both sides by 10. You get x equals 18. So we'll be using these proportions to help us solve similar figures. So we're going to start by determining if two figures are similar. So here are the steps. Number one, you take the first set of corresponding sides and write them as the first fraction of the proportion. Number two, the other set of corresponding sides will be the other fraction. Then we cross multiply, and you want to see if your products are equal. Alright, so this first example, we have these two rectangles. First rectangle has sides of 4 and 7, so that'll be the first fraction. Okay, so side 4 corresponds with side 32 of the other rectangle. 7 corresponds with 56. So now we cross multiply, and we want to see if the cross products are equal. 4 times 56 is 224, and 7 times 32 is also 224. So yes, those two figures are similar. Alright, so figure, or question 2, we have these two quads. We'll see if they are similar or not. Alright, so we have 3 and 5, that's shape 1. So 3 corresponds with 1, and 5 corresponds with 2. Notice how I like to put shapes around my corresponding sides. I've also seen students highlight. It's like 3 goes with 1, 5 goes with 2, just to help you visualize what goes together. Alright, so 5 and 2. So we cross multiply. 3 times 2 is 6, 5 times 1 is 5. Those are not equal. So therefore this would not be similar. So number 1 was similar because the cross products were equal. Number 2 is not. So we talked about how to determine if two shapes are similar or not, but how do we solve for missing measurements? It's pretty similar. Determine corresponding sides, set up your proportion, cross multiply and solve. Do not forget units. Let's try some examples. Alright, so in this example we have two isosceles trapezoids. We know that they're isosceles because these two sides are congruent. Same with this other trapezoid. Alright, so let's set the proportion up. So corresponding sides. So 8 goes with x, and you can use 10 or 14. I'll use 10, which goes with 15. Understand that there's not just one way to solve these proportions. So we have the first shape, 8 over 10. The second would be x goes with 8, so that'll go with 8 over 15. Alright, so we cross multiply. 8 times 15 gives you 120. So we have 10x equals 120. Divide by 10. You get x equals 12. Let's try using the 14 just to see if we get the same thing. So 14, let's say we use 8 over 14 equals x over 14 goes with 21. Okay, so 8 times 21 gives you 168. divide both sides by 14, and we do get x equals 12. Alright, so excuse my bad drawing, but we have a house here and a tree. So we have x, which corresponds to the height of the house, and 10 that corresponds to the height of the tree. So we know that x goes with 10, and 75 goes with 15. So we'll set the proportion up, x over 75. So first shape is on one side, and then x corresponds with 10, so 10 will be the numerator, over 15. So we get 15x equals 75 times 10. 75 times 10 gives you 750. Cancel out 15 times x by dividing by 15. We get x is 50 feet. Alright, so other examples that you might see. Alright, so number one, we have triangle A, and remember this symbol means similar to triangle B. What is the scale factor from triangle A to triangle B? So what I'm going to do is just pick two corresponding sides. So like 10.2 corresponds with 3.4. Notice how I'm going from A to B, just like the directions say, from triangle A to triangle B. Let's divide those out and see what you got. So 10.2 divided by 3.4, that gives you 3. What if we tried 7.5 divided by 2.5? That also gives you 3. 8.1 divided by 2.7, that's also 3. So the scale factor from A to B is 3. Alright, so another example. So we're given triangle ABC is similar to triangle ADE. So that means that side AB corresponds to side AD, and AE would correspond to AC, and so on. But anyway, what if they give you a proportion like this? Like AB over AD is equal to blank over AE. It's helpful for me, because I'm a visual person, to write it out, ABC over ADE. So what I see here is AB going with AD, then I see AE goes with AC. Some people can just look at the figure and tell that for that entire piece, AC, AE would correspond with that. What if I said BC, which corresponds with DE, is equal to AB, which corresponds with AD. Would that be okay? AB, AD. You can look over here. AB, AD, BC goes with DE. So yeah, that would work. Basically, all you have to do is determine what sides correspond with each other. Alright, example number 3. So we have quad dogs, DOGS, is similar to quad bear. So let's write that out. So dogs over bare. And let's see which of these proportions work. Alright, so A has G and S going with A and R. So this proportion is going horizontally. It's also possible for them to go vertically. But anyway, so GS corresponds with AR, which that is true. And DO corresponds with BE. So DO corresponds with BE. That's also true. So A would work. Let's look at B. So B has DO going with BE. Looks like they're going horizontally too. And then they have S and D going with AR. So that does not work. So we'll get rid of B. Let's try C. So OG is going with AR. Does not work because OG should go with EA. Finally, we have SD. So this one's actually going vertically up and down. SD going with AR. That doesn't work either. So the correct answer would be A.